So this morning we went through quite an extensive review, but at the beginning of Part II of 20.3.1, we are dealing with a review as well. So we might as well, before we write this little quiz, just go through this review to make sure we're all on the right page. And then we will come back and talk about, after the quiz, which should be about 5 minutes, talk about what we're going to be doing today and get at it. So as a summary from quote yesterday, we have that vertex form of a quadratic function, which is f of x equals a times x minus p quantity squared plus q. The coordinates of the vertex, this should be child's play really. They are p comma q. You can choose to understand why, or you can just choose to know that that's the case. The reason why is the p shifts the parabola p units left or right based on whether p is positive or negative. So if p is positive 5, the parabola is going to be shifted 5 units to the right, which means the vertex will be over at x equals 5 somewhere. That leads us right away, I'll get back to the q in a second, to the idea that the equation of the axis of symmetry is x equals p. Because the axis of symmetry is that vertical line which divides the parabola into two mirror images, or two halves that are identical except for them being opposite to each other. Just like your left glove and your right glove, or your left foot and your right foot are the same but opposite. And if we shift it p units horizontally, then that location of the axis of symmetry will be at x equals p. The reason why the y-coordinate of the vertex is at q is because q is dealing with the vertical shift up or down. And if q is positive, then it shifts up that number of units. If q is negative, it shifts down. So if q is negative 5, the y-coordinate of the vertex will be at negative 5. What I didn't say in all of this is that the reason the vertex is at p comma q is because it starts off at 0 comma 0. Then it undergoes the shift of p and q. If the vertex form is that, okay, this is just a continuation. And you need some help with this, but if the parabola opens upwards, that must mean that a is greater than 0. And if it's opening upwards, then there is a minimum value. This is going to be something that could easily catch you, because you have these positive words. A is greater than 0. You're thinking positive. And then we say it opens upward. You think up, that's positive. And your brain can easily be cajoled into thinking maximum because of all these positive words. But if you look at what a parabola looks like that opens upward, it has a minimum. And when we talk about the minimum value, we're talking about a minimum value of y. I didn't really explain this. Maybe I should have. I hope you understand that this graph that you're looking at does not have a minimum value of x, because it just keeps going to the left forever. It's not x that's the minimum, it's y. And the minimum value of, I'll put y equals q. It's going to be the y-coordinate of the vertex. If a is negative, then the parabola opens downward, so this is what it would look like. And I know most of us can probably go, okay, if a is negative, it opens downward. That's an a, by the way. It might look a little bit like a q. It opens downward. You can picture it in your head, and you can see that it looks like a hill, and there's a top of the hill, but some people may need to draw it. So it has a maximum value of q, and it's y, right? I think it's important that if I said what is the maximum value, I mean, technically you could just say q, but you should say the maximum value is y equals q. What else have we got here? There's a vertical reflection, which simply means the thing will go from opening up to opening down if a is negative. The vertical stretch factor, which is something that phrase that I introduced this morning in our seminar, The vertical stretch factor is the number that tells you how many times taller it gets or how many times shorter it gets. So if the vertical stretch factor is 2, the parabola will become twice as tall. Well, that's the absolute value of A. Right, and I introduced that absolute value concept this morning as well. And all that absolute value means is don't worry about negative. If A is -5, then it reflects vertically, but the stretch factor is 5. The vertical shift is Q units up if Q is positive, and Q units down if Q is negative. And the only reason I put absolute value signs around the Q when we talk about Q being negative is that if Q were -8, I would never say -8 units down. It would be 8 units down. And the horizontal shift is P units to the right if P is positive, and the absolute value of P units to the left if P is negative. That's it, right? I mean, what you have to be able to do for the quiz, I'm not going to give you this as the quiz. I'm going to give you a specific quadratic function where you would have to know what A is and what P is and what Q is by looking at it. So I'm going to give you about 5 minutes to do this quiz. You are not allowed a graphing calculator for this quiz. You should not need a calculator at all. There's no calculations involved. Oh, excuse me. There you go. Oh, sorry. You're welcome. You bet. And a reminder, just in case you weren't here in seminar, if you missed the exam yesterday, it needs to be written today after school or Tuesday of next week after school in the exam room. About quadratic functions. You'll probably get those quizzes back a little bit later today, but under the examples of this lesson, the first set of examples asks us to find the intercepts of a quadratic function. And I'm going to remind you from grade 10 that X-intercepts are where y is equal to 0. So let's just let that sink into our brain. If you were to look at a graph, any graph, there's an x-axis and a y-axis. And the location of a point is defined by the x and y coordinates. So for example, the coordinates of this point might be 2, 4, because the x coordinate is 2 and the y coordinate is 4, right? So what if I have a graph and I don't care what the graph looks like? It maybe goes through that point, but it also goes through this point. Well, what are the coordinates of that point? They might be -3, 0. If that happens to be where x equals -3 on the x-axis, then clearly the x-coordinate is -3. But since it's on the x-axis, the y-coordinate is 0. Y-coordinates that are positive mean the point is above the x-axis. Y-coordinates that are negative mean the point is below the x-axis. So any point on the x-axis has a y-coordinate of 0. Similarly, or conversely, any y-intercept is always going to be where x equals 0. And I can give you another example. This is -1, -2, -3, -4, -5, and we have a point here that's on the y-axis. If it's on the y-axis, it's a y-intercept. Then the coordinates of that point would be -5, comma, whoops, pardon me, would be 0, comma, -5. The x-coordinate is 0, the y-coordinate is -5. So these are important things to remember. I'm going to erase these points and scales because we don't really need them for this question. That was just a review of why we do what we do for x-intercepts and y-intercepts. So how is it we find, let's say, the y-intercept? I'm going to start with the y-intercept first. By the way, you might make a note that the y-intercept is singular. It just says intercept. But intercepts is plural when I talk about the x-intercepts. There's a lot of reasons for that, but just make a note of it for now. Let's deal with the y-intercept first. The y-intercept is going to be found by taking this equation, y equals -1/2 times x plus 5 quantity squared plus 2, and making x equal to 0. And making x equal to 0. We're finding a y-intercept, so we changed x to 0. Now, if you take a look at what we have here on the right-hand side of the screen, we just have to calculate what that y is. We have to take all those numbers and crunch them together. So I'm going to have y, the y-intercept will be equal to -1/2. 0 plus 5 is 5. We have to square that, plus 2. So we have -1/2 times 5 squared, which is 25, and then plus 2. And the purpose today is not really about algebra at this point. It's about getting a number. So I don't have a problem with you doing this. -0.5 times 25. And then adding 2. And saying the y-intercept is -10.5, but we really ought to convert it to a fraction, which is -21/2. However, at some point, you have to understand that -1/2 times 25 plus 2 can be found by multiplying -1/2 times 25/1. You multiply across the top, you multiply across the bottom, and now you have two things to add. And we have an entire unit in this course called rational expressions that deals with fractions. When you add fractions, let me clean this up a little bit, you want to add the same denominators. We cannot add halves and wholes. So I'm going to multiply the top and the bottom of this by 2. And I get y equals -25 halves plus 4 halves. Listen to how I say that. I don't say -25/2. I mean, it is. I say -25 halves, because then I can say to you it's like having -$25 plus $4. You get -$21. That's why we need a common denominator. So the y-intercept is -21/2, or -10.5. There's nothing wrong with saying -10.5. Let's talk now about the x-intercept, or x-intercepts. I'm going to go to a new page where I have a bit more room. We have y equals -1/2 times x plus 5 quantity squared plus 2. Did I write that down correctly? Okay. So now I'm finding my x-intercepts. You don't need to rewrite this. You've already got it written down. This is where we let y equal 0. So we get 0 equals -1/2 times x plus 5 quantity squared plus 2. Now, I could just show you how to rearrange this, but I want to teach you a bigger, broader mathematical idea. When you're solving an equation, everybody, what you are doing is removing everything from the equation around the x. Okay? And if you take a look, I've talked about this with you a little bit before, but I want to do it again. If you take a look at what's happening to x, and I don't think you need to write this down. What's happening to x is you're adding 5. That's the first thing that happens to x in this statement. Would you agree? The second thing that happens is you square. The third thing that happens is you multiply by negative 1/2. And the last thing that happens to x is you add 2. These are all of the operations that somebody has performed on x. I did when I typed up the question. Our job is to reverse all of that to get x by itself. Have I used the analogy with you before of like unwrapping a present? If you unwrap a present in a civilized manner, the very last thing that I do in wrapping the present is the first thing that you undo. Right? I mean, we know when you unwrap presents, you just unwrap them. Who cares? But, you know, if you're one of those really straightforward thinkers like me and it's got to be done just the perfect way, if the last thing the present giver did was put a bow on it, the first thing you do is take it off. So we have to undo all 4 of these things. We have to not add 5, we have to subtract 5. That's undoing. Not squaring, we have to square root. Not multiplying by negative 1/2, but dividing by negative 1/2. Not adding 2, but subtracting 2. We have to undo all 4 of those, but we have to undo them in the opposite order. So the very first thing I'm going to do is this. I'm going to undo this first because it was the last thing done. So I subtract 2 from both sides. And I'm left with negative 2 equals negative 1/2 times x plus 5 quantity squared. And then I have to undo multiplying by negative 1/2, which means I have to divide by negative 1/2. There's better ways to do this. For example, I would just change the signs on both sides and multiply both sides by 2. But then my 4-step procedure becomes more complicated to explain. So we're going to divide both sides by negative 0.5 or negative 1/2. Of course, what happens over here is that cancels. And you're left with whatever negative 2 divided by negative 0.5 is, which you can use your calculator here. I don't want to get buried too much into fractions today. It's 4. So you end up with 4 equals x plus 5 quantity squared. And by the way, you can kind of see that the reason we got rid of the 2 and then the negative 1/2 is we're slowly getting closer to x. And what we would do now is you'd say, well, I better get rid of the squared. I can't get rid of the 5. I can't open up the box that's in my present until I unwrap the box. Okay. So now I take the square root and I end up with x plus 5 equals the square root of 4, which is 2. You're still with me? There's a mistake that I've just made. Unlike some mistakes I made, this one was intentional. I meant to make this mistake. What is the mistake that I've made here? Thomas? You mean put brackets around the x plus 5? That doesn't matter, actually, in this case. Will? Plus or minus, or positive or negative. Because I'm saying that some number squared is 4, but it could be positive or negative 2. Whenever you introduce, this is what separates linear from quadratic. Quadratic is going to be 2 solutions. How many times does a straight line cross the x-axis? Once. How many times is a parabola? Twice. It's going to be 2 x-intercepts here. So now what we can do is subtract 5 from both sides and get x equals, I'm going to write -5 plus or minus 2. That's how we would write it. It would not be wrong if you wrote plus or minus 2 minus 5. That's not wrong. But we usually put the plus or minus at the end. What does that mean? It means x equals -5 plus 2, or x equals -5 minus 2. The 2 x-intercepts are -3 and -7. If you were to graph this on your graphing calculator, I need a little bit of help here to remember. It was -0.5. Was it x plus 5 quantity squared plus 2? Okay. I'm going to set up my, don't worry about why I'm setting up my window settings the way I am. I'm going to go from, that's good enough, and I'll go -15 graph. There's the parabola. If I take a look at the y-intercept, it's -10.5. By the way, on your calculator, if you know the x-coordinate, you can find the y-coordinate very quickly. You just go trace, enter the x-coordinate of 0, and then hit enter. There's my y-intercept. That's right. We will talk later about how you can find your x-intercepts, but trust me, that is crossing the x-axis at -3 and at -7. In fact, you can kind of see it, can't you? Okay, let's try another one. Oops. Y equals 4 times x minus 7 quantity squared minus 12. So if I find my y-intercept first, which is where I let x equal 0, then I'll have y equals 4 times 0 minus 7 quantity squared minus 12. I would like everybody to calculate for me, please, what that is equal to. I want to say 184. Okay, so -7 quantity squared will be 49. Positive 49 times the 4 gives me 196 minus 12. By my count is 184. The x-intercepts, well, the x-intercepts are found by letting y equal 0. So I have 0 equals 4 times x minus 7 squared minus 12. I guess the first thing I need to do is add the 12 to both sides. I need to move the 12 over. To get 12 equals 4 multiplied by x minus 7 quantity squared. I can divide both sides by 4 now to get 3 equals x minus 7 quantity squared. Now I take the square root. So I'm going to have plus or minus the square root of 3 equals x minus 7. In the previous question, you don't have to write this down. I'm just writing it down for you to look at up here. In the previous question, we had plus or minus 4 root 4 equals x plus 5, yes? And then I wrote plus or minus 2 equals x plus 5, right? So I went from plus or minus root 4 to plus or minus 2. What should I change plus or minus root 3 to? What should I write?
Square root of 3.
Right, plus or minus root 3. Because it's irrational, we've had this conversation before, you don't want to write a decimal value down because it's an approximate value. So all we have to do here is add the 7 to both sides. And those are the X-intercepts. And there's nothing, everybody, there's nothing wrong with you saying the X-intercepts are 7 plus or minus root 3. You don't have to say 7 plus root 3 and 7 minus root 3. I might as well show you now how to find the X-intercepts on your graphing calculator. Okay? Because you're going to need to know this sooner or later. What did we have? We had y equals 4 x minus 7 quantity squared minus 12. Am I right? Okay, I'm going to go zoom standard just to see what happens. That's not bad. And I want to talk about window settings here. When you go zoom standard, everybody, your calculator will go from -10 to 10 horizontally and from -10 to 10 vertically. Okay? When I take a look at this, all of this is wasted space. There is no information there about the graph. So instead of going from -10 to 10, I look at this and I go, you know what? Let's go from 1, 2, 3, let's go from 4 to 10. And by eliminating that wasted space, it's going to take that narrow region that's a narrow looking parabola and it's going to spread it out over the whole screen. I also, because I like to see the vertex, notice that the vertex would be down here somewhere. So maybe instead of going from -10 to 10 for y, I'll go from -15 to 10. So what have I decided to do? I've decided to, so I go to my window settings, window, and I want to go from, I said 4 to 10 would probably do the trick. And I want to go, instead of from -10 to 10 for y, -15. I mean, look at that's so much nicer to look at. It's a nicer picture of the parabola. Now I'm going to show you how you find the X-intercept. And for a reason that I don't really want to get into right now, just remember that an X-intercept is also called a zero. Okay? It's because the function is 0 there. You go to your calculate menu, which is second trace, and you choose 0, which is option 2, and then it says left boundary. So if I want to find this X-intercept here, left is over here. It's to the left of it, and right is over there. All I need to do is scroll so that my cursor is to the left of that boundary. And by the way, you don't have to scroll. You can enter the number. I knew this was 4, so I'm going to enter 4. Well, I'm going to enter 5. I can see 5 is to the left. You put the cursor there. And then I'm going to enter 6. I can see 6 is to the right. And I hit enter. You can scroll and then hit enter. And then it says guess, and I go, I don't want to guess. So I hit enter a third time, and I get this number. If I repeat the process with the other X-intercept, I'm going to go from 8 to 9. And again, you can scroll if you want, and I get this number. Now, what did we get for the X-intercepts? Was it 7 plus or minus root 3? Is that right? 7 plus or minus root 3? Take 7 plus the square root of 3 on your calculator, see what decimal approximation it gives you. Take 7 minus the square root of 3, see what it gives you. It's going to give you those numbers. So it works, is my point. All right, let's take a look at example 2. What is the equation of this parabola? Well, we did one like this morning in the seminar, but now it's officially in the lesson. And I didn't give this to you this way on the quiz, but it's the same idea. I want you to write down what P is equal to and what Q is equal to for this example. P is equal to 3, Q is equal to 1, because the vertex is at 3, 1. This point right here is at 3, 1, and the vertex is always at P, Q. So we can load in now, instead of writing y equals a times x minus p quantity squared, we can write a times x minus 3 quantity squared. Plus, instead of writing q, we can write 1. Now we'll see who remembers what I want you to start calling something like this A. Anybody remember what I told you this morning? You remember, Jack? What is it?
What are you referring to?
I'm asking, there's a special name that I'm calling this letter A in the context of this question.
It's not slope, is it?
No, it's not slope.
Missing parameter?
It's a missing parameter. And I've discovered over the years that if you have the same language, if you use the same language for similar problems, then you start to recognize that you solve these problems all in the same way. So this is a missing parameter. And Joel, can you remember how we find the missing parameter? Whether it's this problem this year or a problem in trig next year, we do the same thing. You can't. It's okay. It's all right. Lucas, do you remember?
You take another point that's on the parabola and put it into your y now.
Right. You pick an ordered pair that's on the parabola and you put it in for x and y. So we actually have 2 points here. We have for x, we have when x is 2, y is 4. So we could put in 2 for x and 4 for y. And then we also have when x is 4, y is 4. I want you to notice something. That if you put 2 in for x, in brackets you'll have 2 minus 3, which is negative 1, and when you square that you get 1. If you put this point in instead, you'll have 4 minus 3, which is 1, which when you square gives you 1. It doesn't matter which point you use. But you remember me showing you that you cannot use the vertex. So I'm going to go with 4, 4, and I end up with 4 for y equals a times 4 minus 3 squared plus 1. This becomes 4 equals a plus 1, because 4 minus 3 is 1. 1 squared is 1. 1 times a is a. So we subtract 1 from both sides and get a equals 3. Now we can write our answer. Y equals a times x minus 3 quantity squared plus 1. I'm going to show you something here. And I still want you to do the missing parameter thing this way, because what I'm going to show you will work here, but it won't always work. If this parabola had a equals 1, then it's the regular x squared parabola, right? You know what I'm referring to? And the regular x squared parabola, when you go from the vertex over 1, you go up 1, don't you? So if a were 1, these would be the points. Look at how far vertically that point is from the vertex. It's 1 away, right? Look at where the point is on the graph we're after. It's 3 times further away. This thing has been stretched vertically by a factor of 3. Let's try another one. This will be y equals a times, well, p is -2, q is +1. Do we have any disagreement with that? The vertex is 2 to the left, so p is -2 to the left of the origin. The vertex is 1 above the origin, so q is +1. So we have x minus p quantity squared times a plus q. This gives us, this gives us y is equal to a times, watch what I do. Just look up here for a second. I go times x minus -2. That's minus a negative becomes a positive. Quantity squared plus 1. Oh, we got a missing parameter. How do we find a missing parameter? You put in an ordered pair. I think this is a nice one to use. 0, -2. You could put in -4, -2. It won't matter. So 0 is, 0 goes in for x. -2 goes in for y. This is kind of like rearranging for the x-intercept, but we're not after x, you're after a. You got to subtract the 1 from both sides first to get -3 equals a times, let's do a little bit of mental math here. 0 plus 2 is 2. 2 squared is 4. So a is equal to -3/4. We have to divide both sides by 4. So now we know a. And now we can throw those three parameters into our vertex form. Y equals a, x minus -2 plus q. Does anybody have any questions with that second part of this example? All right. I want you to take a minute and read C. And now I have a question for you. Is C really any different than A or B? No, it's just that instead of giving you a graph to pull the information off of, I'm giving you the information in a sentence. And I'm pointing that out because sometimes people learn how to do something by looking at a graph and then you give them words and they think it's a different question. This isn't different. This is telling you P is -2, Q is +5. We do not know A, it's missing in action. But if we put P and Q into our vertex form, we'll have x minus -2 quantity squared times the A plus Q, which is 5. You know, the thing that might confuse you here is you have two points, right? You have to know which one goes in for PQ and which one goes in for XY. So when I say it passes through 2, 7, that means when I put 2 in for X, I get 7 coming out for Y. I would like everybody to solve that for A, getting an answer in lowest terms as a fraction. Two plus 2 is 4. 4 squared is 16. So I have A times 16. When I subtract the 5 from both sides, the 7 on the left minus the 5 that I'm subtracting because it's in the way, it's surrounding A, will give me 2, so I have 2 equals 16a. Divide both sides by 16 and you get 1/8. So far what we've done today is looked at how to find intercepts and how to find the equation of a parabola by looking at the graph or by being given the information. There's a couple more things we want to do though, but we'll pause there. Any questions with C? Okay. Here's a parabola. I want you to just take a look at the equation of the function of the parabolic function or of the quadratic function for a. Just look at it and figure out what it's telling you about the function. Okay. I mean, you should look at this and you should be able to basically form a picture of the graph in your head. A little bit. Question is, how many times will this graph cross the x-axis? Without graphing it though. Some of you know almost immediately. See, if you look at parabolas that cross the x-axis in, say, 2 places, they will either look something like this or something like this. I mean, if they open downward, the only way they will cross the x-axis twice is if Q is positive. If the vertex is above the x-axis and it opens down, it's going to hit twice. If the vertex is below the x-axis and the thing opens up, it's got to hit twice. And what we're looking at here for this question A is this Q value tells you that the vertex is above the x-axis. I mean, specifically, it's at -5, 2. But the important part is Q is positive. And since A is negative, it opens down, which means there are 2. If you take a look at C, how many of you see that in C you're not going to have any x-intercepts? The vertex is up at 13, and the parabola opens up. So the minimum value of the function is 13. Well, the x-axis is way below 13. If that's the minimum value and it opens up, it will never reach the x-axis. So there are 0 here. How many of you understand why there's only one x-intercept with B? The vertex is on the x-axis. It's not shifted up or down. So if the vertex starts at the origin and all I do is I move it to the left or the right, it's still going to be on the x-axis, which means there's one x-intercept. I'm giving you this as an example in your notes because the number of x-intercepts is crucial. What we have now discovered from this is a parabola can cross the x-axis twice, it cannot touch the x-axis at all, or it can have only one point of contact. And we have one last example to do. We have a parabolic arch. So this arch that you're looking at is in the form of a parabola. You're given the dimensions here, and we want a quadratic function that models the shape. So I'm going to highlight the shape first of all because this is somewhat of a 3-dimensional diagram. We're talking about this. That's the parabola. Now, here's the interesting thing. We have 26 people in the room, 27 including myself. We could come up with 27 correct answers. Because I might decide, and don't just hold off on writing anything yet. I might decide that I'm going to put the axes here. In which case, my P and Q will be 0 and 0. And quite frankly, that's kind of a smart move. Because then 2 of my parameters are both 0. You might decide, and this is a smart move as well, you might decide I'll have to wait it out. The mice are running around in my CPU. Oh, there we go. You might decide to do this, in which case, and again, you're not writing anything yet. If I do this, then I'm saying P equals 0 and Q equals 0 because my vertex is at the origin. If you do this, you're going to have to say P equals 140 and Q equals 216. And I want you to run that around in your head a bit and think about it for a second. Like, where is this maximum point? Well, if it's 280 centimeters across, then that point is half of 280 to the right. So, and again, we're going to decide what to write down, or you're going to make a decision in a second. If I did it this way, I would say the height of the parabola equals a times x minus p squared plus q. I'm going to use h instead of y. So I would have h equals a times x minus 140 squared plus q. Right? If you do it this way, and I think we're going to do it this way. Let's write this down. You can put your axes on the diagram now. You're going to have y, or h rather, equals a times x minus p quantity squared plus q. You're just going to get this. This is why I think this is a better move. Now, what do we have? Well, we have a missing parameter. How are we going to determine the missing parameter? We're going to have to load in the coordinates of a point. Well, there are 2 points that we can use. You can use this one or this one. Since the width of that arch is 280, the x-coordinate of this point must be 140. And since the height is 216, the y-coordinate must be negative 216 because that point's 216 below the axis. So I'm going to put negative 216 in for h. I'm going to put 140 in for x. And there comes a time in everybody's day where you just go, man, let's just use a calculator. Let's take negative 216 divided by 140 squared and convert it to a fraction, because we haven't got time for that kind of math. Sometimes it seems like we barely have time for doing it properly. So negative 216 divided by 140 squared. I guess I should enter that on my home screen. Math, enter, because we're just, sometimes you just want to use the conveniences you have in front of you. Negative 27 over 2450. Okay. A equals negative 27 over 2450. Did I remember that right? Yes. So what is the equation of the function? H equals negative 27 over 2450. As just a little extension for some of you, it's interesting because if you do it this way, you would put in, well, you know what you could put in? You could put in 0, 0. That's a point on the parabola. And if you put 0 here and 0 here, and I forgot to write in my Q. My Q was 216. Guess what you're going to get for A? You're going to get the exact same value of A. because you'll subtract the 216 and divide by 140 squared. And you get the same value for A because the shape is the same and it opens upside down. Anyway, let's move on to the next question. The final question. What is the height of the archway at a point 50 centimeters from its outer edge? Now, I admit that if you use this picture, it's easier to make sense of the answer. But we want to find the height of the archway 50 centimeters from its outer edge. So look at what this is saying. This is saying here. It's saying, what is the height there? And believe me, if we set it up the other way, it's a lot easier to see how to get the answer. But what I'm going to have to do, first of all, is recognize that this is 90. Because from the center of the archway to the edge is 140. So if we want 50 away from the edge, we have to use an x coordinate of 90. So let's put 90 in for x. I never finished writing down my equation. There's my a times x squared. So I'm going to put in 90. And for this question, we can just go with decimals. If you start talking about design and construction and architecture, let's figure this out and then I'll make my point. We're going to take that number times 90 squared. First of all, it's negative because what that is, everyone, is this distance. That's what we have found. So that's a distance from the top to that point, which is, did I just see 89? This is 89 then. I know it's negative, but it's below, so I'm just writing 89. If this whole distance is 216, then we can take 216 minus 89. And I know that to get the equation here, it's easier to set it up this way. But to answer part B, it would have been better to set it up this way. Because in part B, if you put in 230 for x, you will get the height. But anyway, I have to take 216 minus 89.3. So it's about 126.7. My point is, if you were designing an arch, you wouldn't say to the designer, make it a certain fraction tall. You would give them a decimal. So this is our answer, about 127 centimeters. So far in this unit, this question is equivalent to the bouncing ball question in the very first unit. It's kind of a tricky one to think of. Any questions with that final example? All right, on page 157, 6 through 13 are some practice problems. You know, and I'm fairly impressed with you guys so far as a class. You know that I don't expect you to do every question, but I do expect a certain level of effort and work. Finally, I have to apologize. I got called into a meeting this morning. I didn't get a chance to even start marking your exams, so you will not get your marks until maybe even tomorrow morning. But by this time tomorrow, we'll have a chance to look at them, okay? So get to work, please. I need to do a couple things as usual, and then I will come around and give you a hand.